Now, now we have a quadratic equation that we're going to solve. When you go to solve it, we're going to do it just like we would normally solve it until we get to the end. So if you were to solve this for x squared, how would you do that? Maverick.
Subtract 100 and then divide by 4.
Yep, we're going to subtract 100. We get 4x squared equals negative 100. And then we would divide by 4. And we would get x squared equals negative 25. But you can't leave it as x squared. You're going to have to take the square root of both sides. And the reason I say you have to take the square root of both sides is because the inverse of x squared is squaring something. The inverse of squaring something is the square root. So we are going to take the square root of both sides. The square root of x squared is x. Well, what is the square root of 25? This is one that you probably should know. It is 5. And because there's a negative, that means it's just not regular 5, it is 5i. And the other thing that you need to remember is that if you are solving an equation with x squared, you're going to have two roots, so you're going to have a positive and you're going to have a negative. And the reason you have a positive and a negative is because you are solving this equation. Okay. Number 7. Subtract 4 from both sides. X squared equals negative 4. We're going to take the square root of both sides. You get x equals plus or minus. You only have the plus or minus there because this is the x squared. And we just learned that when we've been solving quadratics, so when you solve a quadratic equation, that's any equation with x squared in it, you're going to have two answers. We're going to take the square root of the 4, which is 2, and then the square root of the negative 1 is I just want to make sure you guys know that once we start solving these, after this moment, if you have to solve a quadratic equation and it has a negative inside of it, like you're going to take the square root of a negative number, I'm going to expect you to be able to pull out the I from here on out. Okay, complex numbers. This part is a real number. This is your real number. This is your imaginary number. That is what a complex number is made up of. It's always made up of one real number, one imaginary number. Always. So this is a Venn diagram, and it's talking about what the difference between a real number is and an imaginary number. So remember that anytime you see A plus BI, A is your real number and B is your imaginary number. BI is your imaginary. Okay, so what I wanted to do is on the back of your notes, it says the Venn diagram shows, so I wanted to show you where the Venn diagram is. And I wanted to show you what makes a real number and a complex number and a pure imaginary number. So a real number would just be the 3, okay? The real number is just going to be 3. The complex number is going to be a number like 4 plus 3i. So that 3 turns into, as soon as you add an I, it becomes a complex number. And then we have our pure imaginary number. And that's just going to be 3i. So again, real, complex, pure imaginary. So the reason that's important is so that you know what is the real part, what is the imaginary part. Because what we're going to do next is we're going to solve for x and y. We're basically going to solve a real part of the problem and the complex, the imaginary part of the problem. So it says as all real numbers are complex, the term complex usually refers to a number that is not real. So what we're going to do now is we're going to solve this for x and y. And in this problem, there's a real section and there's an imaginary section. This right here is my reals. The reason I know it's real is because there's no i's anywhere. So what I'm going to do is I'm going to set it up as real equals real. So real equals real, so 5x plus 1 equals 2x minus 2. Real equals real. Then I'm going to have my imaginary equal my imaginary. And my imaginary is going to be this part. And the reason I know that's my imaginary is because there's an I attached to it. So it's going to be 3 plus 2y I equals y minus 6i. And then we're going to solve it just like we normally would solve it, okay? So I subtracted 2x from both sides. Then I'm going to subtract 1 from both sides. I get 3x equals negative 3. 3 divided by 3. X equals negative 1. So I just solved for my x. So if I multiply 5x times negative 1 and 2 times negative 1, those would equal each other. And that's what we're trying to do. We're trying to solve this imaginary equation. Now, over here, see how there's two i's? It's just, you can drop those. They're the same. So they're going to be there, so we're just going to drop them. Then we would have 3 plus 2y equals y minus 6. I can drop them because if I divided both sides by I, the i's would disappear. Just like you guys, if you divided each side by 6 and there was a 6 on the other side, they would disappear. I'm going to subtract 1 from both sides. I don't know why I just canceled that out. They do not cancel out, you guys, just so everyone at home knows and everyone in third period knows. Those do not cancel out. They equal 3 plus y equals negative 6. Then I'm going to subtract 3 from both sides. and y equals -9. And if you're at home, and if you're in period 3, you can't see that. There we go. Now you can. So you guys, basically, I just set up 2 different equations. One's a real part, one's an imaginary part, but we solved them just like we solved them before. Okay. We're going to do examples 9 and 10, and then I'm going to stop the video. Okay. Just like in the prior, there's a real part and there's an imaginary part. -2 and 1 are my real part. So -2 plus 1. 5i and -7i are my imaginary part. And it's 5 plus -7. So it's 5i plus -7i. And now we're going to combine our real parts, we're going to combine our imaginary parts, and we're going to come up with a complex number. So -2 plus 1. -1. That's my real part. 5i plus -7i. -2i. That's my answer, and that's a complex number. And when you go to answer, you guys, your real part always comes first. In a complex number, always write your real part first. Number 10. 4 and -1 are my reals, and there's a subtraction sign. So I'm going to write 4 minus -1. 6i and 2i are my imaginaries. So I'm going to do 6i minus 2i. So I have a real part, I have an imaginary part, and now I'm going to combine them. 4 plus -1 is 5.